Welcome back to the channel. Today I'm going to demo how we could take this simple thread plug that we've modeled in Fusion and create a full technical drawing of it that we can then send out to get quotes for manufacturing. So stick around. Here we go. All right, we start with the model in order to create the technical drawing, and we also need to have kind of an understanding of what this is. So this is a thread plug. It's designed to slide in the end of a piece of a pipe or tubing, and it's going to be welded along this flange to the bottom of the pipe, and then it allows an adjustable bolt or foot to go in the bottom of it. Think of the bottom of a table, like an office table where you can adjust the height of the feet. This is the piece that goes at the bottom of it. We've made this out of A36 or just standard mild steel. So we're going to go ahead and get started, but you kind of understand the functionality in order to create the model. So first thing we do is we go to design at the top, go to from design for a drawing, and then we are going to choose the 8.5 by 11 sheet for this and click OK. Here is our drawing page. We are going to want to lay out what will be our front view. I am not a fan of this view as our front view because it doesn't really explain what the part looks like. So I'm actually going to show the left, and the reason why I'm doing the left is so that when I place the left and then click OK, and I can project the right, which gives us the original front view, and an isometric, and I can click OK. And those views are views that I think very well convey the shape of the part cleanly to the manufacturer. So the first thing I've done is I have changed this to colored, and I am going to take away the from parent aspect of this, and I'm going to leave it a 1-to-1 scale because I'm going to actually change these to be a 2-to-1 scale to give me a little bit more size, but I want this one to stay small while we're at it. And because it's staying small, we need to make a note of scale here. So I'm just going to write a scale. So I can write scale 1:1, and that is telling the manufacturer that this isometric is a 1-to-1 scale, while this is the scale that goes off here, which you clearly didn't pick up. So I'm going to have to modify that to make it 2-to-1. There we go. And while we're in here modifying, which by the way, I double clicked on this to get it within this, I can go ahead and add IED for my students who are watching this. This is a 50 series part, meaning a Fusion Monday. It's the 15th week, and it's the second part we made in the 15th week. The revision of this is because it's 2021. So we need to fill in the weight here. And in order to fill in the weight, I need to go to the bushing file. Unfortunately, it doesn't auto-populate yet. But I went to the bushing. I had set it previously under physical materials as steel, ASME, A36, which is standard mild steel. And then I can go here and, I can go to properties, and I can record down its mass, which is 3.791 ounces. So then I can come back over here, double click on this, type in 3.791 ounces, and has enter, and I get the ounces in there. All of this is done. We do have a little bit of work to do over here, so we're going to hit the finish sketch, and we are going to adjust in the notes the material, which I am going to label mild steel as opposed to A36, because I'm basically saying they can use any steel they want. This obviously, the more specified here I am, the higher this cost. This is designed to go on the bottom of a table. If this was a part that was going on, say, the aircraft landing gear, then I may need to specify like 4130 steel or even like stainless steel, 316 or 304, depending on its application. And the coating is raw. It will get powder coated after it's been welded to the pipe. So we're asking the manufacturer to just make them raw for us. So we now have all the information set up and we have the page set as we would like. The next step I always tackle is we need to put in our center marks, our geometry marks. So I'm going to put the center mark on this, which makes it look like a scope. And then I'm going to put on the center mark of the horizontal, so I get my 2 center marks. And that more signifies that, hey, this part is round. So our next step is we need to start talking about the dimensioning. The first dimensions I'm going to worry about is here. And so I'm going to dimension from here to here, picking up that line. And that's 1/4 of an inch. And then from here to here is also 3/4 of an inch. In this part, I'm going to specify that I'm going to hold a fairly tight tolerance, plus or minus 20 thousandths for this length, as well as plus or minus 20 thousandths for this length. Now, the overall length is 1 inch. The problem is, if I'm at the top end of this tolerance range and the top end of this tolerance range, it will be over this tolerance range. So what I need to do to fulfill this is I am going to make this a reference dimension. Oops. So if I double click on it and I put a parenthesis in, what I am now saying is that I find this dimension important, the overall length is lesser important, meaning hit this dimension, don't worry about hitting that dimension. So you're telling the manufacturer what is important in the functionality of this. Now, in reality, a leg on a foot probably doesn't matter, but I'm here to teach you new things, so that's what it's there for. So we have the linear dimensions. Now we need the diameter dimensions. We have the outside diameter, and understand these are the 2 critical dimensions here, because this tells the person, hey, I'm going to need to get 1.5 inch stock diameter, and each one's going to be at about 1 inch long in order for us to make this part. Now, this dimension, which is the 1 inch diameter, I'm going to put it over here, of this area here, has a fairly tight tolerance. So what we're going to do is we're going to double click on this, and we are going to go into tolerances and put on limits. And what this will allow is it has to slide inside a 1 inch shaft, a tube with a 1 inch inside diameter. So we need to limit its upper range. So it's going to have 0 ability to be bigger than the number I've specified. But it does have the ability to be smaller by 0.02 in my case. So I am now limiting, hey, its upper range is this and its lower range is 0.98. So thus the manufacturer knows, hey, if I make it bigger than 1 inch, I cannot give it to them. I can make it up to 0.98 smaller and it's still an acceptable part, because you're signifying here that this is an internal mating surface. Okay, so that's important. We have this threaded hole in the middle. That's what the dotted lines represent. So we want to use the hole thread note, which will allow it to pull the data from the file that you created the hole with, and will auto-populate all the necessary information to make that threaded hole for the manufacturer. Now, we only have a couple of other things to worry about. We got these 2 chamfers to worry about. Now, neither of these chamfers are critical. If they were critical angles and dimensions, then we want to dimension them with the dimensioning tool, such as like this, and specifying the starting diameter and the ending diameter. But they're not. This one is simply an edge is cut so that it'll easily slide into the tube. And this one is cut to make the welder's job easier, because if there's a V shape, there's a spot for the weld to go, less grinding at the end. So we're just going to use callouts here, and we are going to call out this one, and we are just going to say it's a 0.05 chamfer. I'm sorry, I did that backwards. Chamfer 2.05. 0.05, what I said but didn't write. And then we are going to do another call out over here, or another leader line, and it is also a chamfer to 0.15. Much bigger chamfer because they're going to put a welder in there. It's going to put in some fill rod. We need more space. So we can go ahead and hit close. So there we go. We got a fully dimensioned drawing ready to be manufactured, and all the information is present, and any manufacturer worldwide should be able to produce this part for you. Thanks for watching. If you enjoyed the content, please hit like and subscribe. Have a great day. See ya.